Welcome to AI Frontiers, rethinking intelligence, trust, and teamwork. In this episode, we explore 58 cutting-edge cs.AI research papers published in December 2025. Our journey focuses on the latest advances in stability, teamwork, explainability, and trust in artificial intelligence, unpacking both breakthroughs and challenges. This episode offers a guided tour through the bustling cityscape of AI research, highlighting the dynamic neighborhoods that drive innovation in the field. Consider this. Can the same artificial intelligence system give you two completely different answers to the same question? Imagine a chess grandmaster who, when faced with identical games, randomly chooses between brilliant and baffling opening moves. Such unpredictability is not a trivial quirk. It exposes a core challenge in modern AI. Even minor changes in phrasing can send sophisticated models down divergent decision paths, impacting critical domains from autonomous vehicles to medical diagnoses. This variability underscores the urgent need for AI systems that are not only intelligent, but stable and trustworthy. Artificial intelligence now shapes how we live, work, and make decisions. The 58 research papers reviewed here, all released in December 2025, provide a comprehensive snapshot of the field's current trajectory. In this episode, we delve into the breakthroughs, pitfalls, and human stories embedded within these studies. The central questions addressed include: what makes AI systems reliable, social, and worthy of trust? Through this exploration, listeners will gain insight into both the technical and motivational foundations of contemporary AI research. To conceptualize the vast landscape of artificial intelligence, envision cs.AI as a vibrant metropolis. Each neighborhood of this city specializes in domains such as language processing, computer vision, robotics, and ethical frameworks. Within these digital streets, buildings represent teams working on speech recognition, robotic movement, ethical reasoning, and automated code debugging. At the city's core lie the principles of logic and learning, while its outskirts blend AI with biology, art, and philosophy. This analogy illustrates the dynamic and interconnected nature of the cs.AI research community. One of the major themes emerging from recent research is the development of agentic and multi-agent systems. Instead of operating as isolated entities, the next generation of AI is expected to function collaboratively, much like musicians in an orchestra who must play in harmony. Examples include teams of robots coordinating on a factory floor, or digital assistants negotiating complex tasks. Work by Shuyue Hu and colleagues demonstrates that even large language models, renowned for their solo capabilities, often struggle with teamwork unless specifically trained for such environments. This highlights the complexity of fostering true collaborative intelligence in machines. A critical shift in AI research involves moving beyond synthetic lab tests to real-world benchmarks. New evaluation protocols such as EcomBench and ReasonBench challenge models to operate within the unpredictable domains of commerce, logistics, and real-life decision-making. This transition is analogous to training on a treadmill and then competing on a rugged mountain trail. Notably, ReasonBench has revealed significant instability in model reasoning, emphasizing the difficulty AI systems face when confronted with the ambiguities and surprises inherent in practical applications. Ensuring trust, safety, and governance in artificial intelligence has become an urgent concern as these technologies are integrated into societal infrastructure. Today, trust in AI is not only discussed, but actively measured and engineered. For example, frameworks like calibrated trust in dealing with LLM hallucinations are bridging the gap between high-level ethical principles and the technical controls necessary for real-world deployment. This evolution is akin to constructing sturdy bridges connecting regulatory guidelines, to the tangible impact of AI in everyday life. Several key findings for recent papers stand out. Research by Hu et al. Reveals that effective teamwork in AI does not simply emerge from larger models. Instead, it requires deliberate training and design. Reason Bench exposes the inconsistency of model outputs, posing reliability risks in critical domains. The Autonomous Issue Resolver, or AIR, demonstrates a novel approach to code repair by tracing bugs through data flow rather than traditional control flow. Additionally, studies show that trust in AI is not binary. Users require contextual information and clear explanations to calibrate their confidence appropriately. A pivotal paper, Towards Foundation Models with Native Multi-Agent Intelligence by Shuyue Hu and colleagues, investigates whether state-of-the-art language models possess inherent teamwork abilities. The central question is whether these advanced models can function as effective teammates in collaborative environments. The motivation behind this research is clear. As AI systems are increasingly deployed in real-world settings, robust collaboration skills become essential. The study provides critical insights into the social dimension of artificial intelligence. The methodology behind Hu et al.'s study involved evaluating 41 large language models on a suite of complex team-based tasks. These tasks required coordination, understanding the intentions of others, and adaptive planning within dynamic environments. The researchers combined quantitative performance metrics with qualitative analyses of the model's behaviors. Their findings indicate that teamwork is not an emergent property of scale. Instead, it requires targeted training, new data sets, and potentially novel architectural designs. The study's scoreboard clearly contrasts individual versus team-based AI performance. The implications of this research are significant. Even the most proficient solo AI models often falter when placed in group contexts. Effective teamwork necessitates the development of new benchmarks, specialized datasets, and innovative system architectures. Risks identified include misalignment between agent objectives, emergent collusion among agents, and poor adaptability to changing environments. Notably, the research team's experience challenges the prevailing assumption that simply increasing model size guarantees better collaborative performance. Looking to the future, the evolution of artificial intelligence resembles a fleet of ships navigating uncharted waters. Progress will depend on the integration of modular architectures, neurosymbolic reasoning, and embodied approaches that combine perception and action. The vision is for AI to become not only a faster or more capable system, but a creative partner, able to explain its reasoning, repair its own code, and collaborate flexibly with both humans and other AIs. The overarching analogy is one of charting safe and reliable routes through the unpredictable ocean of innovation. In summary, the trajectory of AI research is shaped by themes of collaboration, stability, explainability, and trust. Intelligence is now understood to depend as much on effective teamwork as on individual power. The field faces enduring questions. How can systems be built to align with human values? What mechanisms ensure the safety and transparency of intelligent technologies? Listeners are invited to engage with these papers, to question prevailing narratives, and to contribute to the ongoing story of artificial intelligence. This episode was synthesized using the GPT 4.1 model by OpenAI, which provided both structural organization and summary content. Text-to-speech narration was powered by OpenAI's technology, while visual elements were generated using Google Image Generation. A human expert reviewed the material to ensure technical accuracy and clarity. While every effort has been made to present the information faithfully, minor oversights may exist. Full references for all discussed papers are provided for further exploration. Stay up to date by subscribing to AI Frontiers for weekly deep dives into the world of artificial intelligence. Your input and questions help guide future episodes and content. This channel is dedicated to exploring, learning, and discussing the latest advances on the frontiers of AI. In this podcast, we bring you the latest breakthroughs in computer science and AI straight from the arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.